a conversation. All right.
It's recording, don't
It
worry.
is recording now. So let me know if it's not at some point. If we get disconnected, usually it just resets itself. All right, so um, I'm going to put the quiz on today for Ben, but I'm also going to put at 11:45. I'll give you a little more time, like last time, so you can be relaxed. At 11:45, I'm going to put a quiz on for something in the like that we already did. Which one do you want? Which section would you like? I have to talk to you guys about probability. I can put another one for probability because you guys did not do well. But I needed you to use the formula that we studied for 2 hours in class. One or two of you did it right in the end when I gave you more opportunity, but um, so I could put one for I could put two, one for probability and one for regression.
Professor, I think some of the challenges that I'm having is determining which formula I have to use when.
Yeah, you mean in
Um,
probability or in everything?
in general, to be completely honest, like I have my formulas and I just write them down, and sometimes when I read the problem, I'm like, okay, so how do I dissect this problem in a way that I know which formula I'm gonna
Nair, the
use?
best
So,
way is to keep studying, keep studying, keep studying.
okay,
Don't, if you're not there, you just got to keep studying if you don't know, but also I will highlight as much as I can how you know where to go. All right.
okay, thank
But
you.
number one piece of advice is stick with my materials. Don't go outside my materials because you're going to get confused. Stick with what I have there. I know I have a lot, but if you go out onto the internet, you're going to have more, and then you're going to get really confused. Stick with what I give you. All right. That's all I expect from you is what I give you. For the quiz last week, you guys used a formula. Most of you used the formula. I guess you went on Google or something and you got the combined variance formula. No, the one that we did in class was what I wanted you to use that we spent with the matrix. We derived, and I think the confusion may have been because I didn't apply it because I derived it, but then I didn't show you how to put the numbers in, and that might have been confusing. Although the first exercise, if I go back, let me open what I'm talking about. All right, let's see. So we did the exercise because Alice asked me to do the exercise. Hold on.
Can we do the excerpt, the actual,
Yeah, we'll do it.
because it's
But I want to
intriguing
show
for
you
everybody.
my logic
Please.
Uh,
of why I
I
thought you would get it, but I know now you're not going to get it because you're still learning. You're not going to get it. You're not going to see the link. You're not going to take the leap. So we will do it for sure.
Professor, now that you mentioned the matrix, I'm confused because I thought that we do the matrix to get the covariance, but the exercise said that there wasn't any correlation between the two variables. So that's why I wasn't
But
doing
that's
the
why we don't.
covariance.
No, we use the matrix to get the variance. We we do
Oh.
all the partial pairs of covariance and then we put them in the variance. Yeah, that
I
all
thought that the matrix was solely only to do the
the
covariance. So that's
covariance.
why I was
No,
like,
no.
there's no way it
Not
can
just
be the
you, everybody,
matrix.
most everybody. I think one or two got it right and that's it. And I didn't even put the grades yet because I don't know, just didn't get time, but I was getting really in depth about what's going on. I spent a lot of time trying to figure out how to test you guys in a way that I'm really getting information, but then I have to consume, the results. So yeah, I never finished responding or giving you the feedback, but I'm giving you it now. So let's see. I'm going to go back to it's module 7 notes. Module 7 and module 8 are the same set of notes. Oh, sorry, 6 and 7 are the same set of notes. So 6. Yeah. It's not just you, item, everybody got confused. So obviously, I brought you down the rabbit hole and I abandoned you there. You guys got lost. All right, so I think the best thing to do is start where we started last week and explain. All right. I'm going to share my last week this problem. And remember, I illustrated, assuming just a normal distribution for illustrative purposes, I used that and I said, if we multiply by a number greater than 1, we stretch it and the variance is bigger, right? But if we add, we just shift it and it doesn't do anything to the variance. And that was the big aha from this exercise. The weight, or the 100 in front, you didn't think about it like a weight. You guys thought about it like a formula. And then you thought it like, I told you this is a linear transformation. That's like a line, that's the B. And then we talked about the shift and then the stretch. If I go less than 1, we talked about it being more narrow, right? So that's what we talked about. And then I talked about 2 variables in a joint distribution. And I use terminology maybe that's not here. I made it, try to make it simple here, but I think it's easier just to talk about it how it is. So, okay, so there are 2 kinds of things, right? The means and variances, and the idea of linear transformation and combinations in a joint distribution of 2 variables or more. So those are the 2 things, means and variances, those, the formulas for means and variances. And then the second thing is the idea of linear transformations and joint distributions. So in here, this was just introducing you to talking about the mean, and that a linear transformation of a variable linearly transforms the mean. That's the idea there. That's the terminology. And I proved it here in the notes. I didn't talk about the proof, but I made a proof there. And then we apply it here and we did the exercise in class. And then I did the variance. But here I have mean and mean. So hopefully, I don't know, it's not confusing. All right. So here is the mean of 2 variables combined. And all I did was combine them, adding them or subtracting them. And the result is, again, whatever you do to the values, you also do to the mean. So if you're adding 2 variables together, their means add together. If you subtract one variable from another, the mean is subtracted 1 from the other. So that's how that works. So that's straightforward, but it's not exactly the same thing for variance. I went the long way here. So this is actually the formula for variance, doing it by first principles. But what I do is derive some results. And I did that by that example that we looked at and the fact I explained with the formula of covariance and variance that you end up with this squared term. But the shift doesn't do anything to the variance. The shift does not do anything to the variance. It's just the multiple in front, the scalar multiple in front. And just like the values get squared to make the variance, the squared deviations from the mean, so too does the weight in front get squared. So I'm calling it a weight now, but it's a scalar, it's a constant. It can be a number, any continuous number. If it's a number bigger than 1, it spreads things out and the variance becomes bigger. If it's a number less than 1, it narrows and makes a tighter distribution. Between 0 and 1, I would say, because this gets squared anyways. I don't have to talk about the negatives, right? All right. And then the standard deviation is B sigma X. All right, so that was about that drawing. But what about the variance of the sum of two variables? So then I explained that the result that we got that was simple for the means, whatever you do to the values, you also do to the means. It only works for variance if what? What is the condition?
Can you ask that again, please?
What is the condition for it to be this simple?
If there is no covariance between the
There
two
is
variables.
independence.
That's right. This
Independent.
only works if the variables are independent. I say it here. Independent, okay? Put a underline, highlight, double estrella, whatever. That is the condition for it to be simple like that. That whatever I do to the variables, I also do to the variance of the variables. It's not just that simple because there's an extra term. And then I defended with the matrix. I showed you how we derive this formula. We have to think of each pair and their covariance and add all those pieces of covariance together. And that's what we did. And you guys were great at that, but then you didn't know how to apply it. So this is simple. This does not have the weight in front here. So I explained to you with the example we did, and I have the video, the photo of the image on the platform of if we have a weight in front, that how it translates. And I guess I don't have it in the notes like that, but let's look at what I wrote there so you guys can translate it. I'm going to go back. Let me see if you're looking at the same thing as me. Oh, you are. Okay. Hold on. I have to give you the same visual you have, or else you'll get confused. So, all right. So here I have the, yes, here. So if we have a weight in front and we combine the variables, this is the formula. All right. So write that down or have that somewhere, and then we'll go to the exercise and talk about how you would apply in this case. And again, if it's not in my notes, don't use it because you're going to have the wrong answer. There are assumptions of using this model, and I gave you a chance to explain that in your answer where I said, what would make, when would your formula not work? And the assumption here is that you can have this linear relationship. And I did say it in the class, but I mean, it's okay. I wouldn't give big points for, or take off marks for that part so much. I just wanted to see if you understood. And I want to stress the point. So you guys are writing that down, or are you getting that? Okay. And
Yeah, writing it down, Professor.
and it makes sense, right? You guys most of you got it. I think you saw the pattern. You saw that if you, oh, that's for 3. Sorry. We just need to do 2. We don't need the 3, right? We just need the 2. This one here, this 2. We didn't do 3. I was just showing you that if you do 3 or more, it's still 2 because it's the pair in the matrix makes 2. Anyone who wasn't here last class and you didn't have a chance to study, just write it down and you can go back and review. You're going to watch the conferences, conferencias, the lectures. That's the main thing. That's the main thing I want you to see. It's as though you were in class. Then you get through the notes, and then any gaps in the notes, things I didn't discuss, things you didn't understand. That's what we have the sessions for. And we do have this session, and we have 3 more. We have 3 more still. All right, so you wrote it down? You have it? All right, so let's look at the problem, which I put up on top. Oh, because I have it in your view. Does a question come up? All right. So out of this problem, where are we going to find the weights? What are the weights? That's all you had to figure out, really. Because you have the mean, you have the variance. You guys did the mean fine. You did the weighted, well, not all of you, but yeah. Well, anyway, how are we going to do this? So this is like, this is your mu, you can call it mu of A like you did. And this is your sigma squared of A. Be careful because it says variance, not standard deviation. Sigma squared of A. So it's already squared. Does it, you can say that's a trick question if you want, but you have to remember that. This is sigma squared of A. Sigma is the standard deviation, and we operate with the standard deviation. That's what people want to talk about because that's in the same units as the problem. In this case, percentage score or score of 100, or in other cases, percentages or kilograms. Okay. So, but this is already squared. So the standard deviation is 4. And this is the number of students. The score for the second group, this is mu B, and this is sigma square B. And then that's the number. So how many students in total are there?
35.
35. And what percentage of students come from group A? How will you figure that out?
Divided by
35.
35.
Mhm.
20
So
divided by 35. That is your weight. That is the proportion of group A students. And then what is the weight, or what is the, the weight in front of
1 minus the other proportion.
1 minus, or 15 divided by 35? Okay,
Yeah.
those are your weights. So now with that information, can you guys do the variance? You're going to put, that's all you're missing, right? Because you have all the other numbers. I told you here, so this is the independence. So it's independent. What does it mean? All you do is, I give you an easy one. The weight squared times variance plus the weight squared times variance. I knew it was premature to give you a tough problem, so I gave you a simple one, and it confused you. Also because you guys went out of the notes and ended up somewhere else using different formulas with different assumptions and things. So use the formula I have, and then I gave you an opportunity to explain when it wouldn't work. It wouldn't work when they're not really independent. What would independent mean in this case? It means that combining them wouldn't change any of those parameters. And that's a stretch, Some students in group A, let's say they helped the students in group B because they were better students. Now we're changing the mean outcome and the variance outcome. So they're affecting each other. There's a covariance happening. Okay, so that's all I wanted you guys to get at. So try and do that without me, and I'm going to set up my iPad. Item, you wrote 1030. Why did you write 1030 in the chat?
If as if that's the value that we were supposed to get.
Oh, okay. Sorry.
No worries.
Yeah, I thought, okay, yeah. Was it 1030 for the variance? A little bit smaller. I don't know. Is that, I think it was 9 or something. What'd you get,
Um,
Victor?
I was gonna ask because I did to get the weight of group B, but it give me zero point 0.5 and the other one is zero point 0.6, so it's 101.1 in total. Aren't they supposed to add up to 1?
Yeah, well, you did something wrong. What did you do? The weight of
At
A is,
15 over 35 equals zero point 0.5, 20 over 35 equals zero point 0.6.
oh yeah, you need the
15 over
decimals. You can't,
35,
they need
it's
to add, I don't know what your calculator did. I don't know what you did.
I mean,
Hold on.
like 15
They have
over
to add up to 1 just the way you did it.
yeah.
35 is 0.4285 or something like that.
Yeah.
20 divided by 35 is 0.57, so don't round.
Yeah, exactly.
Victor, what calculator are you using?
I'm using a Casio FX
Yeah,
300.
just make sure you can see the decimal places. If it's, yeah, if it's going to do that, it has to add to 1. So use the ones that add up to 1. So yeah, where do you round, right? So I made a rule that you should keep 2 more decimal places than the data. So the data has no decimals, so keep 2. Okay, if you stick with that rule, for one thing, it works because we're using the same approach and then we'll have the same answers. For the most part, my answers use that rule. And on the other hand, it just gives you you don't have to think every time, just always 2 more than the data, 2 more than the data. You don't have to trouble yourself.
Okay,
I
thank
invented that rule myself so I could have some sort of consistency, and it works most of the time. Otherwise, you have to use, there are rules about scientific notation. I didn't want to go that far. We're not a engineering class.
Yeah, I'm still getting 10.3, so I don't know if I did something
No,
wrong.
no,
All I
maybe. I
did,
don't know. I did it. I solved it. I don't know where my paper is now.
no
I
worries.
solved it and I think I had 9. Let me see if I put it in my iPad. I might have done it here. I
I'll
have
just wait until
9.82.
someone
You know
nine.
why? Because I left it. Okay, so what I did was I did not round anything. I left it as a fraction, and then I used that, so I didn't have to round. I didn't round anything actually. Maybe that's the best way to do it.
So just
So I'm
leaving
actually
the
violating my own
fractions.
rule of 2 decimal places. Yeah, I did it with fractions. Yeah. It's funny because I did that instinctually, but I'm looking at it now. Anyway, I would have marked it as correct because I didn't make rules about the decimals, right? But if you want to get my answers in this case, yeah. Let me project what I did. So this is following also from the weighted mean. You know, I had exercises like this with the weighted mean back in GDS. If you remember, if you saw that, there was a weighted mean, and I had 3 exercises with different kinds of data to to emulate, the same formula. Let me show you that. Before I show you this, let me show you that. Mm, all the way back. I have to go back. Oh, great. So, you know, at this moment, I'm assuming knowledge, right? If you didn't learn it properly before, it's going to come up and haunt you. Because I'm going to assume you know it. So you need to go back. If you didn't learn it properly, you got to go back and check it. You should, it's normal to feel overwhelmed with all the formulas. And again, with more practice, you'll know when I'm asking what. And also during the test, I will be there. If you have a question, you can ask me, right? If you don't understand, I mean, I'm not going to tell you which formula to use, but if you're a little bit confused, if there's anything I can help, make sure you learn how to use the chat and send me, oh, sorry, my video's not on. Send me a chat message privately. Okay. So practice doing that if you don't know how. So during the test, you can ask me a question. Oh, someone has a post here. All right. Well, look at that. So what I'm talking about is not here. This is not it. Not here. It was here. This stuff here. So in the weighted mean, I showed you 3 practical problems. How do you calculate your weighted score when quizzes and assignments and midterm and final exam have different weights? So we talked about that. And then how do you get the mean score if the data is like this? This is more like what we have right now. The mean score is this and the class size is that. The mean score is this for the other group and the class size is, so for a total of 60 students. This is what you should have thought about, like, or saw this before. This is what I wanted you to use. So then, and then I showed the data a little differently where you had to create, you had to realize there were many groups. This was just 2 groups, but then this is many groups. In this case, it's easier to just pre-multiply by the number of students and then divide by the total. So there were just 3 different kind of scenarios, but it's the same formula. It looks different, but it's the same formula. So go back and look at that if you don't remember. And then the variance is a little bit different, but this is just for one variable. We're dealing with 2 variables, so not the variance. I just wanted you to get out of that. The weighted mean. Let me show you my iPad now. So yeah, you got 10.3 if you rounded, but I did not round. I kept it just like that those notes on the weighted mean. I kept the weights as fractions and I squared them. So that's more
So
precise because I
from
don't
the
round anything.
so from the formula, we're not using the part that it's like 2 times A times B then?
And why not?
Because they're independent?
Because the word independent, that's right.
So if they're independent, we just use the A times the variance and then B times the variance of the other value. And
Exactly.
we do not use, okay.
Exactly. I gave you the easiest case and you guys went and complicated things. Okay, so this is when they are independent. And then I
So
asked,
that's why I was getting 1030. Sorry that I interrupt. So it's not 1030. My bad.
oh,
Because
okay,
I
okay,
was using the
okay.
2 times. So
Okay,
now I get it.
so it
Thank
works
you.
with 2 decimal places too, you're saying. You still get 9
Yes.
points. Oh,
It's just I
perfect.
added that portion of the formula. But
Okay.
now I see my error. Thank you.
But what did you put for the covariance then? 1?
No, I just did the multiplication of the A and B times. Oh, well, I don't know what I did. I just multiplied 2 values and that was it.
Yeah,
I
you just did you did +2 without the covariance. You did +2,
exactly. That's what, so I'm
20,
like, that doesn't make
35,
sense.
50. You invented. That's very creative, but no, it's not right.
Professor, and you please, you can tell me, if you think we're wasting our time. would you mind just walking us through this? Like I
Okay.
see it
Okay, yeah, it's
here,
okay.
but
It's okay. Okay, so this is the
thank
information.
you.
I'll do it. I'll do it.
Yes,
This is
thank
the
you.
mean. I gave it a notation, just a notation, so you know. Anyway, you don't have to write, but as long as you know it's the mean, that's the variance. So I wrote this to make sure you know that is sigma A squared for the to match it to the formula, right? To match it to the formula. And then this is the sample size. You don't even have to do that. You can just write mean, variance, sample size. And then these are the weights. And you can double check that the weights sum to 1. Which is a stipulation of using this formula. Okay, so if you do it this way, you assume like you create it so the weights sum to 1. And the formula, I didn't even write the formula here. The formula is the long thing, variance of the combined, I can just call it variance of the total or combined, or just leave it like that, is equal to XA squared sigma A squared plus XB squared sigma B squared. And then this other term, 2XA XB covariance AB is 0 because this one
Will only be used when the variables are dependent.
covariant. They're going
They,
when there's covariance. If there's no covariance, I
then
use the
it's
word
0.
independent. There's no covariance. This
Independent.
is 0, so that disappears. The whole thing is gone. I think Nectar, you got this right? The second try?
Uh, I don't remember if it was
You don't remember?
correct, but it was really close, I think.
Yeah.
Uh, oh yeah, I did it. I forgot.
You did it. But the second try, not the first round.
Yeah, the second try.
Even when I tell you guys which formula to use, you guys don't hear it. So you guys got to learn it on you have to really believe it on your own. You have to really figure it out because you won't hear me. So they don't have to be normally distributed. This property is not necessarily that they're normally distributed, even though I think that was written there, or I can't remember. It's not necessary. This is a rule in general. As long as the weights sum to 1, and that will be the rule. So
Perfect. Thank
where,
you so much.
yeah, so I'm gonna put, we can call it P, or what did I call it? Oh, I don't know if I called it anything. Group, the combined group. So the combined group,
It was called supergroup.
oh, the super group. Thank you. You can call it super group, which would be XA. Remember, XA is not 75. Sorry, it's not 20. XA is the weight of 20 students out of the total 35. Is that better, Nair?
Yes, it is. Thank you so much. I
Yeah, no
appreciate it.
problem. It's a lot of stuff. It's easier when I write it step by step. You can copy, but yeah, I put it all. I just flashed it in front of you.
Yeah, thank you.
Okay. So XA. I don't want to put more notation. Yes. All right. So if I give you a problem with a covariance, I tell you the covariance, you put it there. Let me see if let's add a part B here. Let's say if you are told the covariance of AB equals I have to think of a number now. This is hard. Okay, so this is the hard part. So rather than that, let's use correlation. So if I told you that the correlation between A and B, so that the grades, okay, let's talk about correlation. So let's say, like the example that I gave, if I combine them and group A helps group B do better, because group B is like weaker students, and then A is introduced to the group and they improve upon B scores, what would the correlation be? Give me a number. First of all, is it positive or negative? If group A being part of the group improves group B scores.
Positive?
Positive, right? So if A does well, sorry, if B does well, A will do well too, right? There's going to be a correlation. If B does poorly, that's the downside. A is going to be dependent. They're going to do poorly too. So there's going to be a tighter correlation. So it's going to be, we can make it like 0.7, let's say. Okay, so that's going to be if what did I say? Group A helps B or B helps A? Now I'm confusing myself.
A helps B.
If group A helps B. So my point is I have to think about both ways. So if A does well, B will do well. But if A does poorly, B will do poorly, right? So note if A cannot help B, okay, so they're correlated. So then what do I put in the formula? Does anybody know? So I understand correlation. I understand their interplay with this symbol correlation, but now I got to put it in the formula. But the formula has this symbol. So how do I get that from this information? I told you last class, but let's do it together. We'll actually get a number out of here. And you guys are going to be so smart. So how do I find sigma AB? Go back go check what you wrote down at the end of last class, because I did tell you. I don't know if you wrote it right, but check what you wrote. Water.
I don't know if this is right, Professor, but I have B. I have that the sigma of AB. No, never mind. I'll take that back. Nope.
What
Not even
happened?
gonna try.
What
No,
happened?
I don't think. No, I don't think what I was gonna say is correct. So nope. I don't want to confuse anybody. No,
It's
no,
okay, okay, it's
no.
okay. That's their
Sorry.
that's all. It's their risk they're taking. They want to hear you. So this symbol is rho or correlation. This is an R in Greek, but so correlation AB is 0.7. So correlation is, remember, what is correlation? It is the measure of direction and strength of the linear relationship between two quantitative variables. That's one way. But also I told you R was equal to covariance standardized. And then writing it in the symbols, R as Greek letters is the covariance standardized. Do I have all these symbols on my page here? Let's put the numbers we have.
We do.
I have this as 0.7.
Yeah, because
I
that's the thing. I mean, like from last class, what I have here is like PXY equals like the correlation XY over mu X, mu Y.
No, this
Standard
this this
deviation X.
stuff, this stuff
Yeah,
was
yeah,
in
yeah.
this stuff here.
Yeah, exactly.
Okay, so let's plug it in. I have this one. I want this one, but I also have these ones, but I have them as, okay, XY. I guess I have AB here. So let me write it as AB. Let me do that again. Let me do this one again. So let's write it as AB. So correlation AB is equal to covariance AB, sigma A, sigma B. Now you can find it. So this number I told you is 0.7. Yeah, 0.7. This covariance is what I want. And what is the variance? Sorry, what is the standard deviation of A? Do you guys know?
No, it will be 4.
4,
Very good. 4. And the standard deviation of B?
5.
5.
Great. Now you guys got it. So what is covariance AB? Can you do the algebra? 0.7 times 4 times 5.
14.
Yeah. So covariance is a weird kind of number. We don't know how to interpret it. It's just a number we need for the formula. We prefer to use correlation because we understand that number better, right? But in this case, 0.7 times 20 is 14. And that is the number we would have to put here with the weights and everything. So we can do that. So this one, well, I don't have to re-enter this one. I know this already, right? So this is 9.82. Everybody's good with that? I don't want to plug that in again. This is 2 times XA is 20 over 35. XB is 15 over 35. No squares, just the weights. And then 14. So that adds, as long as covariance is positive, it'll make the variance even bigger. When the covariance is negative, it will make the overall variance smaller. It adds 6. Did you get that? All right. So that is the full extent of what I want you to be able to do. One more thing that you should realize is, we had to do all these steps. Wouldn't it be easier if we had another formula that had correlation in it? How can we make a different formula so I didn't have to do all of this here? Is there a way to avoid that, or do I just put it in here? So whatever we did on the side here, if I substitute that there, it's the same thing, isn't it? There's no way to get around it. It's going to be xa squared sigma a squared plus xb squared sigma b squared plus 2xa xb sigma A, sigma B, correlation A, B. Okay, that's what we did. We made this calculation to substitute. So this is another formula. This is another formula, but it's just that substitution for this one. So either you write that formula down too, or you do this on the side. It's up to you. So this is the longest formula I give you. But if you know how to use it, this exercise, if you understand this exercise, you're going to be fine. And in the notes, there are some exercises that make you use that, right? There were, in addition to the one about the Christmas bonus, there were some other problems. And we apply this. Do you want to do one of those problems? Or do you want to look at it yourself and do binomial today?
Can we do one as a group and then we can move to binomial? If that's okay with the rest of the group? I just think we can spend a little bit more time on this since majority of
Yeah,
us
if you can
fail.
learn, if you promise me you're going to learn it and we never have to go back again, you have to
I'll
promise
do
me.
my best to retain it.
We're gonna try. We're gonna try, Professor.
I'm just teasing. I know it's hard.
I
It's
guess
hard.
I have a question for you, Professor. Like, what's a good tip for us, like, to remember that this is like the type of formula or like the type of route that we should
Well,
be
this is
going
there's
to?
nothing else. I don't have another variance formula for you. So this is how you
So,
remember. So this is
okay,
if I ever ask for um combining or a joint, I don't even use the terminology joint distribution, but these are the results of a joint distribution of two variables.
okay.
So the big distinction is between a linear transformation and two or more variables. The formulas were different, a little bit different. Not really, but for you it must look different, but they're the same. Like there's the same principle that you have the weight in front, that the weight makes the variance bigger. If the number is greater than 1. I don't know. Let me see. Let's see. Just don't go outside of my notes. If you find yourself going outside of your notes, ask me first. So at least I can guide you out there in the universe. You're going to get lost out there. My notes have been refined in a way that, you know, it's not random what I put there. It's supposed to be simplified. So if you don't get it, don't go outside to go get more complicated. Just ask me. Okay? Ask me. We can meet. I can narrow it down for you. Don't be shy. And I know maybe you feel like, oh, you got to study some more. Just, we're running out of time. So ask me. And now I don't have classes. Oh, I'm going to start a summer class, but just one. So you guys can ask me. All right, let's get to the notes. Let me open.
Which days are you gonna give this class?
In the
This,
summer, I'm
yeah.
giving a no, I'm giving a finance research class. You guys interested? It's an undergraduate class, so I don't even think you could take it. Yeah, no, I'm gonna give yeah, undergraduate finance research class.
Professor, maybe, I don't know if it's me, but I don't know if if you have a time to upload more Connect assignments. I think we
Yeah,
mentioned.
I do. Yeah, I will do it. I will do it.
Okay, it's just I'm gonna miss the next 2 classes for a trip I have planned actually before enrolling. So I'm trying to compensate with some of the Connect assignments.
Yeah, but most important is, well, are you going to be able to study when you're gone?
Ah, maybe
Oh
not a lot.
no. Yeah. Well, yeah. Remember, the Connect is just to give you guys points. I don't think there's much to learn in Connect. I,
Mhm.
I think most learning is with these materials, but you can tell me if I'm wrong. All right, so
No,
I'm going.
definitely. I'm gonna miss the next 2 quizzes. I'm gonna come back studying for the final.
Okay.
Yes.
All right. Well, anyway, if on your trip you have chance to contact me, please contact me and keep yourself in check if you're going to continue to look at something in between, because yeah, it's going to be the last stretch, the home run stretch that we're going to do now. All right, so let's look at these exercises. Let me share. Am I sharing? You're watching me? Oh no, you're not watching me.
Yeah,
Let me
we
share.
could see your iPad.
Yeah, but that's not what I'm going to
Oh,
be
okay.
on the screen now. All right, so here. So this exercise here, you see, applies it, you see? So I guess I assume you guys did it, or I don't know what I was thinking. But this is applying the same formula here. You see, this is exactly what we just did here.
What is the top of or the title? Okay.
Because
That's page
there's
43.
yeah,
Okay.
there from page 42, 43, 44, and 45, there's several problems that I want you to practice. So you practice those. Oh, there's also here one more, 47. And I have all the answers except, I think I have all the answers. All the answers are there. You have to sit and you have to see it. You have to write it because it's not the same to read it. You see, here's that formula again. You see, this is what we just did. I just showed you. Same thing. The weight squared, the variance plus the weight squared times the variance, and then 2. Then these are the weights. And then these are the then this is the replace covariance formula here.
The one that we just saw.
Yeah.
in-
And notice the weights here, the values here didn't even sum to 1. You see this? This is a new variable. So this formula works. The weights don't even, don't have to sum to 1. In our case, the classroom, they did because the students made up the entire class and we got proportional weights. Here, I'm just creating a new variable. Anyway, you have to read the problem. A new variable with 50 of each to make a new variable for the total. So you have the question depends on the question, you know. I wanted the average from the class or the total for the, you know, what would be the average on a test from the class. That was different than this one when I want the total. The total is different. So that I know it's a little different. So that's why you guys got to study these and see what's similar, what's different in these problems. So this one is I create a new variable, define a new variable. And from there, you get the mean and the variance formula. Whatever I do to the values, I also do to the mean. So the mean formula looks like this. But then the variance formula just takes the weight in front square. And you see the same formula that we did before. So the only difference here is I don't average them, or I don't get the weight out of the total because I'm trying to get the total. I don't want the average score. So I don't know if that's more confusing, but anyway, that's why I want you to study these 5 problems. They're all a little bit different. I think it's 5, but I wrote exercise 6 for some reason. All right, so you guys are going to look at that, and right now, oh, you want me to do one? Okay. You want me to do this one? You want to do this one with the luggage, which is very practical because people are taking vacations. You're going to go to Epic in Disney in Orlando. My neighbors just went. Epic
My
World.
oldest sons, both of them went, and they said it was amazing.
Wow, what did they tell you?
The ride, that, but it was so crowded that some of them, they were not even able to ride it. So, but they were overwhelmed with excitement.
I haven't seen. I just saw I saw images of the people there and the lineups, and I can only imagine how amazing. My neighbors went. The little boy is 6 years old, so excited, and I'm happy
I'm
for them.
in Atlanta, so I was just telling my husband, it's like we should drive, and he's like, we are from the he's from the Dominican Republic, and I'm from Puerto Rico. I'm like, we don't drive more than 5 hours, so
Yeah,
no, if we go, we're gonna fly. There's no way we're going to drive to go to the parks and then have to drive back. So
no
we'll see.
way. No, I hope you can do it. Are you thinking about it? I vote that you go and tell us everything next
It
week.
would be, if we do end up going, it would be more on the fall break that my girls have, and not
Okay.
right
Okay. Okay. Yeah, and you know, it's nicer when it's quiet. Go on a Monday after all the big holidays, and yeah, you don't want the lineups. But you have to really like to do rides, right? And I'm not a big fan of roller coasters. But I did last summer. I went on roller coasters, and it's good. I mean, I think every time I go, I think I'll be better at it. I just wish I was more closed. I don't like to be in the air without something to hang on to. Oh. Anyway, but it would be fun to see how they've created these worlds. It's Epic World. That's what it's called. Epic World.
Epic
Yes, it is.
Universe.
Yeah,
I just
Epic
remembered. Okay,
Universe.
Epic Universe.
Yes.
Okay, okay. Okay, guys, I've never been to Disney World, so I think it's time to go soon, right? All right, so okay, you guys, let's look at this problem. I'll give you 5 minutes, and then we'll talk about it for maybe 10 minutes, and then we're gonna go to do the binomial stuff because I have a quiz for you on binomial. Okay, so I'll give you 5 minutes. You can take get some water or something. I'm gonna pause the video. Remind me to put it back on. Recording again. How'd it go? How far did you get? Without looking at the answer.
I think I got the W correct. It would be like 50x, which is like the weight of the checked luggage, plus also the weight 50 because it's 50 passengers, so that's why I get the 50 for each of the variables. And then Y would be W would be 50x time plus 50y, if I'm not
Okay, so
mistaken.
there you go. So we have two variables, right? We have the check bag and you have the carry-on bag. Look at this interesting data. Try and be interested. Don't just be scared for your grade, guys. So this is interesting exercise, right? So the total, how do the planes figure it out how much luggage to allow so that they don't exceed whatever parameters for weight that they can have to get the plane safely in the air. So they come up. So here we have information about, they also tell you it's normally distributed. I didn't tell you that before, but the normal distribution, that feature is so that we can do part C. Part C is asking for an approximate probability, and the assumption that X and Y are normal allow us to make W is also going to be normal. And that's a result that comes out of SDS. Okay, SDS will give you that result. I prove it for you that if you combine in this kind of a way with a weight or like a weighted average or a linear transformation, the resulting new variable will also be normal. And that makes estimation really easy. Okay. All right. So I'm going to project what I'm looking at. You guys have the questions, right? So you want the sum and then you want the mean and variance. That's the goal here. So you see this, that's the new variable. We create the W, 50x plus 50y. And now we're going to get the mean. So what is the average? What is the mean of W? So that's part A. Part B is find the mean and variance. Well, the rules tell us that when we combine two variables, what will their mean be?
The product of them is that like you well,
Whatever I do to the variables, I also
it
do
will
to
be
the means. So the new mean will be the same pattern, 50, the mu of x plus the mu of y. And I show you guys kind of like with the distribution and saying, you know, if I shift this over, sorry, if I multiply this, no, in this case, I'm looking for the mean. So I'm multiplying every value of x by 50. So everything, you know, multiplies by 50 and it spreads out the distribution. And I'm going to do the same for y. But the mean doesn't change, right? It's just the same because I multiply everything by 50 and it spreads everything out around the mean. So the mean stayed in the same position just 50 times. And that's the same for the y. So that's why the new variable is just the sum of those. And so we can calculate this because we have information. What was the mu of x and what was the mu of y? It was 50 for x.
and 10 for Y.
Does everybody see that information? You guys see that information provided?
Yes.
So now you have the new mean. So 3,000. Okay, so the average for 50 passengers, total weight of the baggage on the plane, if that's all they put, because sometimes on planes they put cargo, they put other things for shipping, they put Amazon packages, I don't know. I guess Amazon has its own planes now, but they put other things on the plane. And then we want to get the variance. Okay, so this is a little bit longer. we're going to write sigma W square. And what do we have to write here? The formula. What's the formula? The weight of X is 50. They tell you, so you just put a square on it, and then the variance of X. The square on the weight of Y, and the variance of Y. And then 2, which formula? Okay, well, I'll write down the original one, right? So it's going to be 50 and 50, because that's X1, X2, the weights. And then covariance. Do I have the covariance?
They're giving a row though.
They're
They
giving the
don't.
correlation. They're giving you the correlation R or rho, which is -1.
Mhm.
Sorry,
0.1.
-0.1. How will you get the covariance from the correlation? We just did that, you guys. What was the formula? I hope you wrote it down. Go back and look.
It was row
It was
times
Y over X is Y X, yay.
Well, correlation XY is covariance over sigma X, sigma Y. But I want to find
R.
this one. So how do I get it?
It will be row times sigma x
You
sigma
have to
y.
multiply, right? And do an algebraic multiplication. So you got to put this, you got to calculate this from the information they gave you. So we have this. Sigma X and sigma Y was given. So I'll just write down everything that I have from the information given. Standard deviation was 30 for X, and sigma Y weight was 10. Sorry, the mu of the carry-on was 10 because they're smaller, and the standard deviation, not the standard, yeah, standard deviation, be careful, is 3. All right. All right. So now you guys can tell me what the covariance is if they tell you the correlation is negative 0.1. So what does it mean? What does negative 0.1 mean? Can somebody tell me and interpret it in terms of this problem? What does it mean? What are the variables? How do we interpret this? The variables are the weight of a carry-on and a weight, well, X is the weight of the check bag and Y is the weight of the carry-on. The higher the weight of the check bag, what happens to the weight of the carry-on?
the less the weight of the carry-on that it's
That's right,
allowed
because
on
they
the
stick
plane.
more in the checked, so there's less in the carry-on. So that makes sense. It's not a strong correlation, but it's a, there's a -0.1 there. So it's more likely to be less. Okay, so now put all those numbers together here. Negative 0.1, 30, and 3. So if it helps you just to remember this formula and then just do the calculation on the side, do it that way. Or you can have the second formula where you put it all in there. The concern I have is with an extra formula, there's so much information there, you might lose something. You might forget a piece of it. So is it -9?
That's the result I got,
Yep.
Professor.
Okay, so it's negative. So that's so the covariance is going to be, sorry, this is going to be negative. So it's going to bring down the variance. So that's interesting, right? So yeah, you're putting checked together with carry on, but you know, more of the check, less of the carry on, and it kind of averages, you know, it becomes you know, less variance total, or lower variance as a result. So you put all those numbers in and you get, so be careful with the squares again. This is going to be 30 squared. That's a big number. And this one is going to be 3 squared. It's a big number. And then all of this stuff with -9. Let's see if you get it right. It's going to be a big number. Okay. And then you need the standard deviation. So you take the square root. I asked for the variance, I think, in the problem though.
Yeah, you
And
asked
standard
for the
deviation. And
okay.
standard deviation. Yeah. Okay.
So we're okay if we use this formula, but we're also okay if we just replace row in this
Yeah, you can
third
put it there
formula that you
too.
gave
Yeah.
us.
Just be
Okay.
careful. Don't miss something because there's a lot
No,
of
yeah.
yeah, a lot of numbers there.
Thank you.
And you guys can see the practical side about this in planning. It's a very practical exercise. Aha, Nictor got it. Without looking, right? You punch it in without looking at the answers because you need to be able to do this on your own. So we're going to finish this and I'm going to just say a couple of things about C. We're not going to do C because I want to do binomial before 11. So one way, I'm going to show you how I would do this on my calculator that I asked you guys to buy. Not everybody bought it, but you can figure out how to use your own calculator to do this or whatever tool you have. You could put it in Excel. That way you can make sure you didn't make a mistake. But how I use the BA2 Plus is with the storage keys. I take these two. I would say 50 square times 30 square equals, and then I'll store it in 1. Store 1, we'll store it in memory 1. There are 10 memory slots. And then I'll recall them to add them up. Actually, maybe I should write that instead. So it's going to be in store 1. So I have to say recall 1 to add it to recall 2 to add it to recall 3. That's how I do it efficiently. So that means, so that's in store 1. Then I would clear and go 50 square times, well, 9, 3 square, and store 2. And then 2 times 50 times 50 times 9 negative is that store 3. And then I add them all together. Recall 1 plus recall 2 plus recall 3. Anyone want me to do that again?
Yes, please. I missed what is the actually
The store?
button for? Yeah,
Okay.
where
So
the
this
S?
is the button here.
There
Do you
you go.
see?
Okay, yes.
Yeah. And you have to hit store first. You have to have the value on your screen. So 50 square times 30 square. Now I have the, well, sorry, 50 square times 30 square is that it's really big. 50 square times 30 square. Okay, so that's that. Then I hit store and the number 1 slot because there's 10 spaces. There's store 0, store 1, store 2, store 3, all the way till 9. So there's 10. And you can see the memory. So I'll store that in 1. You can see the memory by hitting second mem, and you can see everything you stored. So there's nothing in memory 0. There's my value in memory 1. I can use the arrows to scroll. And this takes care of the fact that there's a negative. You won't mess it up. It stores the negative with it. Okay. So that's how I get that result.
I think this method, you mentioned it in the binomial videos.
The storing?
Yeah,
Ah,
yeah.
okay. The storing. Yeah.
I
Yeah,
got
yeah.
that from.
Yeah. That's from the binomial too.
Yeah.
Yeah. So use that skill, that tool, save time, make you less crazy, repeatedly punching in. All right.
I,
So
I don't know why my result was like 2,277,491 for some reason.
you have a number wrong. Verify.
So I mean, like on the third store was like 2 times 50 times 50 times my -9, right?
Yeah, because well, yeah.
So like -9
Maybe
is
it's
is
negative. So maybe you added instead of subtracted.
no, I mean like I just put like -9, like -9
Oh no,
equals
no, times 9, yeah.
times 9. All right.
Yeah.
Okay.
I'm glad we resolved that. Okay.
Okay. Yeah.
All right. Any questions about this? So now the standard deviation will be smaller. So recall 1 plus recall 2 plus recall 3 equals standard deviation is 1,492.48. And these are all in pounds, right? Believe. So the mean total is 3,000 pounds, and the standard deviation is 1,492. And because of what you're going to see in SDS, W is also normally distributed. And guess what? You have its mean and you have its standard deviation. So you can solve this problem by standardizing what is the approximate probability that the total weight limit will be exceeded. And the total weight limit is 3,100. Right? Oops, I lost my page. Oh, here. Okay, so what you would write is for part C, find the probability that W, the total weight is greater than 3,100. That's what you're going to solve. You have to standardize it to make a Z. How do you standardize it? 3,100 minus the mean of 3,000 divided by the standard deviation. You could, to avoid the issue with decimals, just put in the square root 227,500, 2,227,500, and then standardize. And you see, it ends up being a number you recognize. Zero 0.67, 0.067, I believe. And I'm not going to go into it anymore, but you can finish that there. So this is the result. This is the result that comes, you're going to see in SDS that's all you have to do. You assume a normal distribution now, because if X and Y are normally distributed and this is a linear combination, W is also normally distributed. Okay, questions about that? The probability ends up being 0.47. You can check your work. So the chance that they will exceed the weight of 3,100 is almost 50% chance. They're comfortable with that. They either have to use bigger planes, because that's kind of risky, 50% chance of exceeding the weight. If something happens to cause a plane, any kind of mechanical errors because of that would be concerning. All right. Are we good? I'm going to go to binomial. Any questions about this? This was not so bad. It just, you have to find an efficient way, keep your note, everything tight and clean, so that you do not make a mistake, or you can actually find your mistake if you make a mistake. Okay, we interpreted what correlation means here. Let me know if you have any questions about that. And I want to jump into binomial. How many of you guys, if you don't have any questions, how many of you finish the binomial part of module 8? Okay, kind of. So it's the shortest, well, I think it's one of the shortest units. The main thing I want you to gather out of binomial is that you know how to recognize a binomial distribution. In other words, you also know what is not a binomial. Like, so let me go back. You know how to recognize a binomial distribution. You know how to recognize a binomial phenomena, like a situation where a variable has a binomial distribution. I should be more specific. So you should be able to recognize a variable that is binomially distributed. And so you should also be able to recognize if a variable is not binomially distributed. I gave, there are a few exercises about that. Let me go back to so this is a very short unit. Once you understand the binomial distribution and this formula, you're on your way. And I spent some time and it looks pretty menacing, but I go step by step. And my goal is that you understand it so that you're not just copying the formula every time, because every time you copy without understanding, you risk making an error. It's better to understand it. So I have all these problems here. I solve these problems. You have the clave for everything. You also have on the platform I have given you some extra videos, practice assignments, and this has the homework exercises, the solutions. I have all the solutions typed for you. All right, don't look there until you try the problem though, because you're going to think you understand and you do not understand. Binomial solves a lot of problems, like common types of problems. So it's really good to be able to identify a binomial so that you can apply the formula. In unit or module 6 and 7, I solved problems that were binomial problems, just using probability theory rather than using the binomial formula. Okay, so it can be done. Binomial formula is just a simplification of what we understand. So what is a binomial? Who can tell me what are the conditions for a binomial distribution?
Is it that there's two modes?
No, not two modes, but two something.
Possibilities.
Possibilities,
One is
that's what you meant.
success and then failure.
Right. So this example here where I describe the variable, the number of tails observed in flipping 4 coins, and I listed the answers, like the possible outcomes are you flip in 4 coins flipping, you might get no tails. You could get 1 tail, you can get 2, you can get 3, you can get 4. So there's 4 possible tails to get, but you might not get any. So there's actually 5 possible outcomes of that 4 flipping coins experiment or setting or scenario or phenomena. And below, I listed what they would look like. So this is what it would look like to have no tails. It would be that all of the coins show a head. Everybody understands what I mean in flipping a coin? It's a standard statistics analogy, I guess. And the other extreme is you get you get all tails, 4 tails. And in between there are combinations of heads and tails, 1 tail, and this looks like this, 2 tails could look like that, and 3 tails looks like that. So we saw this back in module 7 or 6, but now I'm going to identify this as a binomial, and I'm going to apply the formula to figure out, in this case, what's the probability of 2 tails. Looking at this, the probability of 2 tails out of 16 possible outcomes, 2 tails could show up 1, 2, 3, 4, 5, 6 different ways. So 6 out of the total, there's a total of 16 possible outcomes. 6 out of 16 is the probability, and that's using probability theory to get that result. So this, we already know the answer here, but we want to use this simple exercise or example to create a formula that we can use for more complex things, like what if we want to observe 1,000 people going to Epic Universe, and we want to see if they have a camera rather than a cell phone. Like, how popular are cameras today? So we're going to observe 1,000. Am I going to write this all down and look at, how many, am I going to create the whole distribution, making a list and writing it on paper? No, I'm going to use the binomial distribution to make estimates of what I expect to see. Okay? Make predictions of what I expect to see. So the binomial distribution underscores sampling theory, and you need to know it well. So I spent a lot of time strengthening your understanding of it. So you guys should have gone through and looked at all this stuff. But the first step is identifying that you have a binomial. So what made it a binomial? The fact here is this is a binomial because first, there are two possible outcomes every time I observe. Either you see a head or a tail. So that's one criteria. Second, I know the number of times I'm going to flip the coin or the number of times I'm going to look. I'm going to look 4 times. So that's the second thing. I need to know how many times I'm going to look for the things I'm looking for. In this case, tails. And the third criteria is, well, you guys tell me, what's the third? So one is, so I'm going to look many times and I know how many times I'm going to look. That was the second thing. The first thing I said was each time I look, I can only see either what I'm looking for or something else, not what I was looking for. And the third criteria is what?
That the probability is
Reality.
the same for each observation or
Success
each
and failure.
success.
So the third criteria is that I know what the probability is of seeing the thing I'm looking for each time I look. So I know how many times I'm going to look in advance. Each time I look, I can only see one of two things, the thing I'm interested in or not seeing it. And the third thing is I know the probability of seeing the thing I'm looking for each time I try. The binomial formula takes that scenario and it looks not just at each time, but it looks over the total of 4 times in this case. And it says to you, I'm gonna be able to predict out of that, out of those trials, out of that experiment or of that sample, how many times or what's the probability of seeing the success that you're looking for no times, 1 time, 2 times, 3 times, 4 times. So it's rolling it up. It's like out of all the times, what's the probability of seeing any of the possible outcomes? And you create a distribution. This is the probability distribution. And I just showed step by step how I evaluate this. And I develop a formula for the general case that looks like this. And the general formula has a pattern. There's a pattern to binomial distributions that can be symmetric, but it doesn't necessarily have to be symmetric. So in this case it is, look here. This one for 0 is the same number as the number for 4. The probability of 1 is the same value as the probability for 3. So it's symmetric. The number in the middle is different. That's okay. So this is symmetric. It has the same shape on the mirror and from the center. It's the same shape. It's symmetric. It's not normal. Why is this not normal? Because it's binomial. It's a different distribution. So it's not normal. It's symmetric. Okay. Symmetric just means it has the same pattern from the middle, looking either way, mirrored. So
Professor, could you
Mhm.
please explain what the exclamation points mean?
I don't worry about that. I explained it in the video. I'm not going to talk about it here, but
Okay.
I explained
Yeah.
it in the video. So the quiz I'm giving you is just identifying binomial. So you don't have to actually calculate anything. You just have to know what I'm talking about right now. So I explained in the video that this is programmed in your calculator, but the exclamation actually means when it's 4 exclamation, it means 4 times 3 times 2 times 1. But because 1 doesn't change anything, we don't write it here. And this one, so 4 minus 2 is 2. So that's why 2 exclamation is just 2 exclamation. So this is called, these are factorials. And this is something you would have learned maybe in high school grade 10 or 11. Or maybe you never learned it. But That's what this means. So this is giving you how many ways there are of seeing 2 successes in 4 tries. That's what it's giving you. And it helps you using probability like theory. I'm gonna call it probability theory. It'll give you the answer 6. But you can get this out of your calculator. I'll show you how to do that.
So, Professor, very quick, when you mention the expectation that we're going to be quizzed on, is that the identifying a binomial distribution means that the outcomes, right, they're going to be exactly the same on the both sides.
No.
The
Okay,
mirror.
let me finish.
Sorry.
Okay, so yeah, I got
Okay.
interrupted. So let me finish what I was saying here, and then I'll go to show you how to get that. But you don't have to calculate this right now. No, a binomial distribution is a binomial distribution. It's a discrete distribution, not continuous. A normal distribution, what kind of distribution is it? Is it discrete or continuous? Continuous, because it can be any value, it can be decimal values, any number in between, right? It can take on values in between, like height and weight. A matter of your instrument that's measuring the precision of that instrument, it will determine, what values you can estimate or calculate, or measure. But in fact, it's continuous. It could be, if your tool was even better, you can get even more precision. So binomial outcomes are discrete: 0, 1, 2, 3, 4. So that is not a continuous distribution. All right. However, having said that, in SDS, I make the bridge from binomial distributions to the normal in certain situations. And one is that you need the symmetry. But binomial does not have to be symmetric. In this case, it is. What makes it symmetric? That was my question that I was going to ask. What makes it symmetric?
That the probability of the success is 0.5.
If the probability of success is 0.5 and you're always using the same formula, if the 0.5 is here for P, it's going to be 0.5 for 1 minus P. And that's why you get the symmetry across. Okay. Now, there are other conditions you're going to see in SDS that make it symmetric. And you guys, I'll leave that for you to see. But in general, that's the first step, is to see if it's 0.5, a P is 0.5, it's going to be symmetric. But binomial distributions don't have to be symmetric. Okay. Let me show you something here. So I spend time in the video talking about binomial tables, and you can not binomial tables, but calculating the binomial distribution. And you guys see that? Yeah. So you can get tables. You can generate, now that you have Excel on your calculator, your computer, you can generate tables like this, where you choose for binomial distribution. Okay, for a normal distribution, what you need to know is the mean and standard deviation. If you know the mean and standard deviation of a normal distribution, you know the shape, you know what it looks like. You can make predictions, okay? You can standardize and make predictions of probabilities, for instance. For the binomial distribution, the parameters you need are N and P. What is N?
The population.
The number of trials, the number of times you're going to look for a success, the number of trials.
But I thought that what X, or?
I'm pointing at N. I don't know if you can see that.
No, X is the number of successes, right?
Yeah.
At
N is the number of successes.
yeah. And
Okay.
N, anyway, go back to N and P. X. Okay, so the parameters of the binomial distribution are N and P. N is the number of trials, and P is
The
The
probability,
probability of success.
the probability of success.
So
Oh,
say it longer. So it's a probability of success on any given trial
okay.
each time. Is the P going to change from trial to trial?
No, it's the same.
It will always be the same. Why is it always the same?
Is that binomial distribution?
No, 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 no. Why is it always the same? That's cheating.
Symmetry.
Independent?
Independent, because every time I try, the setting is identical. In other words, every time I look in Epic Universe to see if somebody has a camera, the person walking, I'm going to look at just one person per family or one family. I'm going to look at a family if they have a camera. And so that family separate from another family, if that family has a camera, doesn't it going to affect if the other family or the chance the other family has a camera, right? So I'm going to assume they're independent and I can use the binomial distribution. Remember what independent means. Okay, so those are the parameters. So here we have the distribution. Given different levels of P, this whole this I can't really highlight it, but from 0 to 4, 0 to here, n is 20 in this case. So they give you a table for each different n and a select number of p's, because p is continuous, but I fix it. I say, oh, well, the chance of a person having a camera, like a fancy camera, not just a cell phone, is 10%. Let's say I believe it's that. I can predict at Epic Universe that 4 people out of 20, this is the probability, no, not this one. This one? No, this is the cumulative probability that 4 or less, this is 4 or less will have a camera. The chance that 20 people will have a camera, if my prediction was 10%, the chance that 20 will have a camera, I don't know, this is a terrible table to use, but that's how you read this table. Okay, so you can get probabilities, and this, when you see this kind of table, this is a cumulative binomial probability table. You can also get the binomial table that is not cumulative, but I'm not going to get into it. But you can create these tables for yourself in Excel using a binomial function. So that I teach all of that in the videos. These are all cumulative. They're saying 2 or less. All right, so I want you to be able to identify a binomial distribution, and I demonstrate that with a quiz at the beginning. Oh, that's not it. I'm pretty sure I do that. It's in the video where I say, is this a binomial or is this not a binomial? And you guys have to know. So basically it's that. Questions, I'll take questions from you.
But I think in the video also says that to see if it's a binomial, I mean, like we need to find x and p and k.
Well, that's to solve it. You need to
Yes.
find x, n, and p, yeah. And k is the number. All I want you to do for this quiz is to be able to tell if a distribution or if a set situation or a variable is binomial. You need to be able to find n, and you need to be able to identify p. And you need to know what n means, and you need to know what p means. Yeah, n is the number of trials, and it needs to be known. And P is the success on any given trial, and it needs to be known. Otherwise, it's not a binomial. Okay, so you need to be able to tell me if it's a binomial, and you need to explain what N and P are, if it is binomial, and if it's not, you have to tell me if the problem is there's no N, or if it's a problem that you don't know P, or P is not well defined. That's going to be the exercise I'm giving you. Okay, any questions? Are we going to go into the platform again? I'm going to stop the video unless you have questions for me.
Profesora,
Dime.
¿puedo hablar español?
Sí.
¿Cómo nosotros podemos como saber cómo vamos en general en la clase hasta el momento?
¿Cómo? How do you know where you stand in the class at the moment?
Sí, ¿cómo vamos en cuestión de
Well,
nota, por decirlo así?
the quizzes are a total of 20 you go with I'm going to put all the grades up that you don't have this week so you'll know. But it's by the evaluation. Where's my evaluation?
To the top,
Oh,
Yeah.
right there.
so it's 35% for the 5
Ahí.
best. So you won't know because if you didn't finish the quizzes already, you're still going, so you don't know. So 35% of your grade. The exam is finals 35, 20% is your participation for the 5 classes that you came and connect. So this is an ongoing thing. I don't know if you could know yet, but you just have to perform well on the quizzes and make your connect exercises and
Y,
be in class. You won't know to the end.
y habrán 4 asignaciones más de Connect, ¿verdad?
I'm going to put some more, yeah. Mhm.
Ok.
So you can get
Entonces,
the 5.
repasando para el examen final, vamos a elegir un día, unas fechas que ustedes nos van a brindar dentro de un horario y lo vamos a coger igual como cogemos los quizzes, con la cámara encendida y todo así,
Exacto.
igual.
Yeah. We can talk about it more next class, but yeah, because we have to go to the quiz. So let's get out and come back. But yeah, that's the idea. Okay. You have
Okay.
to be available at I'm going to put 3-hour blocks and you have to choose which one you want. And I'm going to give you some options between those dates. The 16 I'm traveling, so I'm going to erase that date. So it's going to be 17, 18, I think, and 19. I have to see what the final date for the grades are. I might change that. But somewhere in there, you need 3 hours available that you can be working on the exam, okay? Okay, let's stop and go to the quiz. I'll see you back here.